A breath of fresh air is a great thing to be and an even better thing to have, right? Every day, the world keeps advancing. Numerous technologies are being created to make the lives of humans easier and more efficient. We humans continue to create things in order to make the world a better place to live in. Or is it? Nowadays, people would always think about the benefits of technology in their daily lives and forget about its negative effect on the environment. Because of the rapid modernization, our natural resources are depleted and our environment is polluted at a fast rate. Air is essential to the survival of numerous species that live on Earth, including us humans. We've got to pause and ask ourselves, how much clean air do we need? It is not too late for us. Indeed, rapid modernization can also be a way to preserve fresh air. In this info video, let us all dive deeper and learn more about the causes of it. Know more about what we can do as an individual to restore the air we breathe again. Let us start the discussion with Alexandra.
As humans makes huge impacts on the oxygen that we breathe in every day. These impacts come directly or indirectly from our actions, known as anthropogenic effect on our environment. An example of anthropogenic effect on our environment is deforestation. This is the act of purposely killing trees and forest lands. This is a threat to our air as fewer trees are planted to clean the polluted air that we breathe in. And sometimes, due to a very hot and sunny day, a fire could start in a forest which then wipes out a good number of trees. The trees are important to us, to our oxygen production, to our carbon cycle, as our air gets cleaned through photosynthesis within our forests. Another anthropogenic effect on our environment is the use of fossil fuels. Air-related harmful impurities into our air that makes us sick and causes our environment to become polluted. According to Denchak 2018, fossil fuels are being used every day through large factories, transportation, power plants, coals, gases, and oils. The use of fossil fuels every day continues to generate hazardous air pollutions and contribute to climate change. In relation to air pollution, this is where carbon dioxide cycle takes place. Carbon dioxide cycle is also known as carbon cycle, in which it prioritizes reusing carbon atoms from humans, animals, and infrastructures. Trees are the main actors of this cycle. First, of course, is the sun, and then there are the trees. And all of the carbon dioxide that are from these animals, humans, and infrastructures, factory for example, goes all the way up in the atmosphere. And then, it is possibilities which turns to oxygen, and then goes to these animals. The key takeaway in carbon cycle is that too much carbon dioxide affects our environment trapped deep within the atmosphere. If trees are gone and too much carbon produced from fossil fuels and deforestation are produced, the excess carbon will stay at home. Without trees, our bodies and even animals are harmed by the lack of clean air for us to breathe.
Prior to answering this question, we first need to know that the amount of matter on Earth is concerned, and this matter, biotic and abiotic. The transformation of matter between biotic and abiotic forms the biogeochemical cycle. Oxygen, as a member of its lungs, plays an important role in the biogeochemical cycle of the Earth. Nearly half of the Earth's crust is oxygen. It is to be noted that 21% of the atmosphere is composed of oxygen, which is extremely helpful for us humans as we need oxygen to survive. Talking about the importance of this, let us move to the next question. How does it cycle? Production and use of oxygen are involved in a cycle called oxygen cycle. First, oxygen is produced by the plants, and some of it is produced when the sunlight reacts with the water vapor in the atmosphere. Then, it is used during the respirations of humans and animals, and is also used during the composting and decaying of of plants and animals, burning of things, and oxidation of metal. This process uses oxygen and then release carbon dioxide. Let's take a simple example. When the sun rises, the plants take energy from the sun and carbon dioxide from the air and water to make their food and then release oxygen back. This process is called photosynthesis. When the oxygen is released, plants and animals take it and exhale the carbon dioxide for it to recycle again.
Just from reading it, we can have an idea of what invasive species are. To define invasive species, these are organisms that are not native to the earth, yet they are here, which in turn can cause harm to the environment, as well as the economy of the earth. Sounds bad, right? So who are these invasive species that when it comes to our earth? Different pests were able to go from one place to another, which makes them an invasive species in the area they are in. One example is the Mediterranean fruit fly, where through airline luggage, it can go to different places. It originated from Africa and has now spread to Hawaii, Europe, the Middle East, Western Australia, and Central America. Its egg deposits harm the fruits and also fruiting vegetables. Its larvae also feed and may infect secondary diseases on the plant. One organism that is also thought to be an invasive species are the humans. However, are we? It is apparent that we have caused harm to the environment and to other living organisms. But looking at the definition of invasive species, some criteria fit and there are those that do not. Invasive species need the facilitation and aid of humans to move to another place. Humans do this by themselves. We are not an invasive species, but we cannot deny that what we are doing paved the way for the different invasive species that have affected different organisms. Other human activities also led to the destruction of the environment.
A few groundbreaking studies in the last 5 years, notably in the last few years, have stood out sufficiently to be noted on epigenetics. Understanding epigenetics and epigenomics and the genome-wide conveyance of epigenetic changes has grown in importance as it has become clear that understanding epigenetics and epigenomics will be critical in business related to numerous different subjects, requiring an exhaustive comprehension of all parts of hereditary qualities. For example, undifferentiated cells, cloning, maturing, manufactured species, species preservation, advancement in farming. Many epigenetic mechanisms have been identified, including methylation, acetylation, phosphorylation, ubiquitination, and spoliation. Other epigenetic components and ideas are likely to emerge as the research progresses. Epigenetic processes are normal and necessary for some organic entity capacities, but when they go wrong, they can have serious negative health and societal consequences. DNA methylation is possibly the most popular epigenetic process, to a small part because it has been the simplest to research with existing technologies. This is the expansion or ejection of a methyl group, or also known as CH3, which occurs mostly where cytosine basis occurs sequentially. DNA methylation was initially seen in human disease in 1983 and has subsequently have been observed in a variety of illnesses and disorders. Many observers believe that epigenetic work should advance if it is to continue kicking off anything fresh. In their study, Jones and Martinson state that there should be more advancements in high throughput technologies, insightful approaches, computational abilities, robotic exams, and bioinformatic methodologies. They also claim that essentials such as standardized reagents and a consistent stockpile of antibodies for testing are required. Preston agrees with many of these ideas and adds that there is also a need to promote a comprehensive count of all protein in the cell, as well as improve protein change data. He claims that institutions are seeing the interest and the gifts required to address epigenomics challenges and are extending their efforts to cover those topics in many ways, notably at the PhD level. As little would like to believe, the rapid acceptance of epigenetics hundreds of years after it first appeared is a huge step forward. We've done almost nothing up to this point, he admits, and one-sided, but a glimpse of something broader is genomics and single nucleotide polymorphisms, where at the bottom of the iceberg is epigenetics.
Thank you for that, Nicole. It is true that we are all affected by the pollution we produce in the air, which contributes to global warming. This is a problem for the environment we live in since the climate is changing faster than some living creatures can adapt. Sea levels are rising, glaciers are melting, forests are disappearing, and species are clinging to their precarious existence. As we live our modern lives, we humans have contributed to the past century's warming by producing heat-trapping gases. However, just as we contributed to the increase in air pollution, we may also help to reduce its impact. What is the single most important way in which we may have an impact? Speak up. Promote the use of renewable energy sources. Invest in energy-efficient products. Practice waste management. Oppose deforestation and consume wisely. Become a part of the solution, not the problem. Express your worries and encourage others to be concerned about global warming. We may not see the effects of air pollution daily, but we will regret the time we wasted ignoring this issue in a few years. We benefited from this planet. Thus, we must take care of it responsibly. Consider what our future could be if we continue our reckless behavior. Even worse, would there be a future for us?